Hello again. We're still on the topic of authentication and authorization, and we're more specifically talking about protocols versus just straight concepts or techniques. The next topic we have is within the authentication authorization method is called AAA. AAA actually stands for authentication, authorization, and accounting. Authentication gives the computer right to access the network. Within the authentication feature, again, our most common method of doing this is username and password. We also can add multi-factor authentication, which would include biometrics, smart cards, this is something you are, something you have, tokens and certifications, etc. The second part of our AAA protocol is authorization. And basically, what rights does the account have? The last part is accounting. And this is actually logging and auditing. So when we talk about logging and auditing, again, we're just kind of looking at things are sent to a log server, and from within that log server, and someone, an administrator, an auditor, can go through the logs to determine what's been done. Now we have within the AAA family of protocols, we actually have two standards. First one's called Radius. The other one's called TACACS Plus. Now there is, that is a plus sign, there is a TACACS standard. It's important that you understand TACACS and TACACS Plus is not a derivative or a new version of TACACS. TACACS is different in the way it was actually conceived. So just keep that in mind. If you do see TACACS and someone says they're TACACS, verify that. because most people are TACACS running TACACS Plus. This is a protocol developed by Cisco, and we'll discuss that in a few minutes. But Radius stands for Remote Authentication Dial-in Service. So you can imagine this has been around a while. And within the Radius system, we actually have 3 devices. So you have our database of username and passwords. We have our network access servers. And we would call this a NAS. And the last thing we have is the systems that want to connect to the network. Sometimes we call these clients. Within the Radius family, a couple things you got to be aware of. The network access server is highly critical, and it is very important that these stay up. So typically, when we have a system running Radius, we usually have multiple network access servers. And this does support multiple network access servers. And it's important that you understand that you have 2 of these on your network. The protocols it supports are PAP, CHAP, and MS-CHAP. It uses UDP ports 1812 and 1813, or UDP 1645 and 1646. Our TACACS Plus protocol, again, this was developed by Cisco. Stands for Terminal Access Control System. Plus. It was developed by Cisco to support routers and switches. and it's very similar to radius. Now, even though it was developed to support routers and switches, you can't use this for other authentication mechanisms. Just most other operating systems don't support TACACS. So just keep that in mind. Some do, some don't. You're more likely to find applications that support TACACS versus operating systems. At the same time, you can now use radius for routers and switches. So, and Cisco does support both. So just keep that in mind. You're not limited to TACACS, although Cisco does do a few things with TACACS that no one does. And if you're willing to put the deal with that, it's actually quite a powerful system. One of the areas I've used TACACS for on the accounting side is to actually audit what's happening. Not to figure out who did what, but what was actually done. One of the examples I give, and this actually happened to me, I had modified a switch, and when I modified the switch, I lost connectivity. So I was like, I didn't think I did anything wrong, but once I reestablished the switch connection again, and trust me, it involved a ride in the car. But once I got that done, I was able to go through the TACACS logs and realize I actually mistyped a command. And it was that simple. I was, hey, what did I do wrong? So it's important to these can be used for to figure out what people are doing on the network, but it's also use them as training moments, teaching moments. It's like, wow, I did something real. I really botched that up, didn't I? So, and it was easy to do, and I have shown staff a few times. Again, I don't use it a lot, but every once in a while something changes, and someone says, hey, the one thing drives a supervisor manager up a wall is something changes, and people will tell you, oh, nothing's changed. You go looking through a log, and sure enough, something did change. So just keep that in mind. It can be used as a training moment. So again, we're still on TACACS CS Plus. This does use TCP port 49. And it does separates authentication authorization and accounting into different processes. And like Radius, it supports PAP, CHAP, MS CHAP. It also supports MD5 hashes. Then we have the ability of using the Kerberos protocol with this one also. For the authentication scheme. So we can use the Kerberos process in that, and we'll talk about Kerberos like right now. Kerberos is an authentication protocol. It is independent of the point-to-point protocol. So they are separate protocols, and for the point-to-point protocol is really old. It was developed with dial-up in mind. The Kerberos was developed and designed for TCP/IP networks. It's been adopted by Microsoft and used quite extensively within their platform. It relies on three things: the key distribution center, the KDC, the authentication server, and the ticket granting service. Or TGS. It can use TCP or UDP port 88. It does have one very big weakness, and like I said, it also had the same weakness of a pass protocol. If your authentication server is down, there's no authentication. And this is really important because unlike a lot of other systems, like within, say, the Cisco just generic environment, once you authenticate, you maintain that authentication until you log out. Within Kerberos, especially the Microsoft version of Kerberos, there's no re-authentication every 15 minutes. So if that authentication server goes down, yeah, you're logged in, you can be typing away, you're doing stuff, but if that AS goes down, in 15 minutes, everyone's going to get kicked out of the network. It requires an authentication piece there. So when you're designing this, design this with two authentication services on the network. Now Microsoft will put the authentication service within a domain controller. And everyone who is familiar with Microsoft you'll always want to have 2 domain controllers at minimum on your network. So again, if the authentication server is a domain controller, you should always have 2 of those on your network. The other thing that's really important within the Kerberos is timestamps. And these must be in sync. So yeah, Kerberos is a very, very time-oriented protocol. So keep that in mind when if you're working with Kerberos. You need to have, time is very, very critical to this protocol. The way this works, you can have your workstation is going to request access to a resource. This could be a file server, a printer, any kind of network resource. And then you're going to have your authentication server out here. Your authentication server usually is going to may double also as your ticket granting service. So your authentication server can be both. So your device wants to log in. It's got a login request. So you have a login. You're going to send across your login request, and this is just a request. This is actually there's no there are no credentials at this point. Your ticket granting ticket is sent back, basically saying, "Hey, log in." This is a ticket granting. Your ticket granting service sends back a ticket granted ticket. At this point, you're going to send your authorization, or request authorization. And then if you're authorized, you're going to get another ticket granting ticket that gives you access to the resource. So it's a multi-step process. And this login procedure here, this login request, remember this and the authorization can reoccur every 15 minutes. So just keep that in mind. At this point, we're going to go back to our talking about protocols again, but these are going to be encryption protocols. On these encryption protocols, it's important that you memorize the name and the ports that are being used. On some of them, there'll be some additional information, but you'll want to know the name and the protocol, the ports that they're using. So the first one is called Secure Shell. Also known as SSH. This is the protocol. Remember back in the day, a few weeks back, we talked about Telnet, how Telnet's kind of a remote keyboard or remote entry to a network device, such as a router or a switch. A secure shell is the encrypted version of Telnet. So it is similar to Telnet, but it is encrypted. So it uses TCP port 22. Now the other thing about this, not only is it similar to Telnet, SSH can actually be used to establish a secure tunnel between any two devices, similar to a VPN. So there are a lot of protocols that will use TCP port 22. Secure FTP, for example, is one of them, and that's really just the FTP program or protocol on using SSH as its transport mechanism. The next we've talked about in the past, but you'll see it again, is SSL or TLS. And this is authentication and supports authentication and encryption. It does require a certificate. And that certificate usually is going to have an associated certificate authority, or CA. Again, oh, you know what? I made a mistake here. SSL. Again, SSL has been broken. We don't use this. The reason we talk about SSL, for whatever reason, we typically refer to sessions like HTTPS as SSL, and it's not. It's actually running, the more modern versions are running TLS. And you got to watch this one, this protocol. They will find vulnerabilities in these protocols, and when they find the vulnerabilities, when researchers find these vulnerabilities, they will upgrade the protocols, and that's what happened here. SSL was broken, it has some vulnerabilities in it. TLS 1.0 came out, 1.1, 1.2, and we worked to 1.3. So just keep that in mind. These are upgraded on a periodic basis. Within the SSL framework, we supported encrypting HTML, which is used by HTTP, FTP, and SMTP. So those could all be all these protocols could be encrypted using SSL. we're going to break here a little and treat TLS separately for a minute, even though we talked about them both for a second ago, because they're very, very similar protocols. Again, we don't use SSL any longer. TLS was its replacement or is its replacement. So TLS stands for Transport Layer Security. And this was an upgrade to SSL. And it operates in a lot of ways like SSL. But the one nice part about TLS, there are no application restrictions. So like SSL, we can encrypt HTML, SMTP, FTP, but we also have things like VoIP. We can use this as a VPN, and you'll hear the term, they call it SSL VPN, in reality it's a TLS VPN, and others. And we include HTML when it's running TLS. That's the HTML. I'm sorry, we'll get the HTTPS moniker or to start with. Now, all of these protocols here so far have been really upper layer protocols. We're talking transport or higher layers. The next layer, next protocol we're talking about is IPsec. IPsec is a layer 3 encrypt tunneling protocol. So this operates at layer 3. It stands for Internet Protocol Security. Again, IPsec. It supports authentication and encryption. Again, this is the layer 3 protocol, which is the network layer. So the three protocols we've talked to, or the protocols we've talked about, the network layer, are our routing protocols, ICMP, and now IPsec. This does have two modes: transport mode and in transport mode just the payload is encrypted. The IP addresses are in clear mode. So we just encrypt the payload. So payload only. The second mode is called tunnel mode. And in tunnel mode, we actually even encrypt the IP addresses. Next protocol we have is HTTPS. This uses TCP 443. Right now, HTTPS accounts for around 45 to 50% of the traffic on the internet. It's rapidly scaling up. By the end of 2020, experts expect to see upwards of 60 to 70% using this protocol. And the goal set forth by organizations like Google and Facebook are to get 100% of the traffic using HTTPS on the internet. Now, there are some very positive things using HTTPS. Encryption is a good thing. There's some bad things. It makes it really difficult to troubleshoot some applications. So just keep that in mind. This is you don't want your credit card and social security numbers and all that stuff out there, but at the same time, and you don't want that stuff in plain text, but at the same time, it's very hard to troubleshoot. And from a security standpoint, it's hard to break into those protocols without doing something that's some people would consider illegal, but it's called a man in the middle. And sometimes that organizations will do that, but capture traffic, decrypt it internally, but they won't. They got to be very careful when that happens. So just keep that in mind. Common problems we have with HTTPS are expired certificates. When you go out and buy a certificate, that certificate's good for a very specific period of time. 6 months, 1 year, 2 years, 3 years. You used to be able to get 5-year certificates. I haven't seen one in a long time. Usually they start with 3 now. When they expire, your browser will get display a message along the lines, something along the line that says, "Hey, this certificate's expired. Are you sure you want to go there?" If you know the site's actually legitimate, good. They just let the certificate expire and most likely an accident. You can continue on to the site. Be careful if it's a site you've never been to before, because if you've never been to that site before, it might not be an expired certificate. They may have the wrong certificate out there. And sometimes the URL doesn't match the cert. This error you get on your browser that'll say, https google.com is or the site you're trying to go to, google.com, is displaying a certification that it is google.net, something along those lines. Just be careful when that happens. Sometimes it's an actual legitimate error from the person who ordered the certificate. Sometimes it's a malicious activity taking place. You can also have revoked certificates. These are the ones you really want to watch for. Expired certs happen because people don't have a process in place to check for certifications or certificates that are expired. They just don't have a process in place. URLs don't match. This happens because of lack of expertise within the certificate. You're just ordering the wrong certificate. Rather than a multi-domain certificate, you ordered a single domain, and your server name for some reason changes. The application changes the server name. There's any number of things that can happen there. They ordered a single domain instead of a multi-domain. It happens. It's happened to me. Someone called up and said, "Hey, Bill, I need a certificate for this server." I looked at that server, saw the name, ordered the certificate, and they used a different, remember DNS? They used a different CNAME within the process, and the certificate failed. So it does happen. Revoked certificates. Certificates are revoked for one reason. There's been a security issue. The credentials have been stolen. Someone's hacked into the company that supplied the certificate. Someone's hacked into the company that bought the certificate and stole the certificate store. So keep that in mind. That's very, very dangerous if you see a revoked certificate. We're here under expired. If you know the site's correct and you're positive it's correct, you can still continue on. URLs don't match. That you got to watch out for in that one, because that can be tricky. But if you see revoked certificates, run. Just get off the website. Don't flush your cache. Get off. Leave it alone. SCP is the Secure Copy Protocol. This is SSH enabled. So guess what port it uses? The same protocol that we had for SSH. Some people will call this Secure FTP. But it is not an FTP protocol. Just keep that in mind. It is a copy protocol. So some people call it the Secure FTP protocol, but it's not. It's not FTP based. So keep that in mind. Again, Secure Copy Protocol, SCP, port TCP/22. SFTP. Guess what this one is? It's SSH enabled, file transfer protocol. And this also uses TCP port 22. The difference between this and SCP is that this is a secure file transfer protocol, so it is FTP based. All the commands that you'll use on the command line for FTP will work here. So just keep that in mind. This next one has both secure and unsecure modes, and it is called SNMP, or the Simple Network Management Protocol. Now, the SNMP is based on a database called a MIB, or a Management Information Base. Now, I said there were unsecure and secure versions of this. This actually did not start off as a secure protocol. A lot of these didn't, but this one simply added to it. So we have 3 versions. We have version 1 and version 2. These are not secure. Version 3 is a secure version. They use SHA 1 or 2. It's a 2, not a Z. And AES encryption. There are two different ports that it uses. One is UDP port 161, and this is SNMP. This is SNMP. This one is used by a server that will go out and query a device. We use SNMP to query network equipment for performance. We're looking at hard drives, memory, CPU utilization, network utilization. And on port 161, our server reaches out to this network equipment's file servers, routers, switches, firewalls, other devices, and queries and asks the questions. What's your hard drive utilization? What is your CPU utilization, etc. The other piece of it uses UDP port 162, and we call this one the SNMP trap. What the trap does is the device that we're querying, or is out there, the router or the switch, when something hits a trigger, we'll say hard drive space fills up, or there's a network error, CPU utilization hits 100% or 99% or some number, that is an exception. That SNMP trap will be sent back to this computer that runs this database and says, here's an error on this on this device. And the last protocol we have for this chapter is called LDAP, the Lightweight Directory Access Protocol. This is very similar to Active Directory, if you've ever had to work in Active Directory. In fact, Active Directory is actually based on LDAP. That's a D. It uses TCP and UDP ports 389. There is a secure version of this, and they call this secure LDAP, and that uses TCP port 636. It also uses SSL or TLS encryption. And what this protocol actually does, it actually will query user databases. And the reason I said Active Directory is based on LDAP, LDAP's been around long before Active Directory. There was a protocol called X.500, and Active Directory is truly based off of that. But LDAP was around way back there in the X.500 days, and it's a way for us to query those databases. That's it for Chapter 10. We'll get into Chapter 11, which is Virtual Private Networks, in the next video.